Now, we are finishing up chapter 4 of the integration chapter with a couple of ideas to try to simplify finding the area of curves that are not, shall we say, they're continuous but they go in different directions. There are inflection points in them. And we're looking particularly at curves that look something like this right here. And so we have these varying degrees of distances from the x-axis. So, we used the rectangles at the very beginning, and we found that the more rectangles we had, the closer to being exactly correct that they're going to be. Another idea that was proposed is the trapezoidal rule. Instead of making rectangles, we use trapezoids of equal lengths apart, which the trapezoids are actually like sideways trapezoids. You take what you normally expect a trapezoid to look like, turn it 90 degrees, and that's what you got here. This is the starting point. This is our A. This is our B for an integration problem. And when we have trapezoids, the formula for that is average base times height. Well, the base here is the pair of sides that are separated by this line that we have that we call the altitude or the height. And so that's going to be B minus A divided by N, the number of segments that we have split it into. And then because it's an average, this is going to be 2N instead of N. And that's going to be multiplying by our Y value, which is going to be the function of X. So N is the number of segments that we split this evenly into despite what my drawings look like. And so the trapezoidal rule is basically that if you take a look at the integration of the function of X, such that you look B minus A over 2N, and you look at all the sums of the trapezoids or the segments that you're going to have here, you're going to end up with 5 lines here. 1, 2, 3, 4, 5 lines. You have 4 segments. If you have 8 segments, you have 9 lines. So each of those values of Y that are calculated from the function of X, as X changes each time, is going to give us our values here. And so this is the general formula we're going to use, and I'll do an example, 2 examples of this actually. So let's suppose that we have the curve is the sine of X from 0 to pi. And so you can graph this if you want, and you can imagine this being divided into 4 parts. So that means there's 4 segments, so N equals 4. So that means each width is going to, each X value is going to be pi over 4, since we divide it into 4 parts. There's going to be 5 terms. And what's really simple about this, and it's kind of a pain of a calculation, but you don't mind using your calculator. What you're going to do is, since we found that this is going to be the average area of the trapezoid, pi is our B, 0 is our A, divided by 2 times the number of segments, which is 4. So we're going to be looking at a value of pi over 8. That's going to multiply this calculation right along here. And these calculations are every Y value that we get for the beginning and end point. So like the first section is the sine of 0 and the sine of pi over 4. And the second section is sine of pi over 4 with sine of pi over 2. The third section is sine of pi over 2 and sine of 3 pi over 4. And then the last section is sine of 3 pi over 4 with sine of pi. This is why we have 2's in the middle and for coefficients and only 1 for the 2 endpoints. So we're looking at each of those Y values there. So that means then that this is going to be sine of 0, start off with. We're going to take pi over 8 times this whole thing. And remember that this is going to be the sine of X. We plug in X, which for the next one, since the pi is being divided in 4 parts, the first one is pi is equal to 0. This is going to be 1/4 pi, this is going to be 1/2 pi, 3/4 pi, and then full pi. Yum, yum. So, and then we put the coefficients of 2 in front. You can simplify it like I did here if you want to, or you can just go ahead and hit pi over 2 parentheses, and then just go through and calculate all that. Just make sure you have all your parentheses accounted for. You should get 1.90. Okay? Now, let's suppose instead of 4, we want to divide it up into 8 parts. Well, this becomes pi over 16 then, because it's 2 times 8, which is 16. We still have 0 for A and pi for B. And remember, we're using the same function for this. And then we're going to go through and do the same thing, only now we have pi over 8 for each of the lines that we're using for our value of the angle. So this would be sine of 0, 2 sine pi 8, 2 sine pi 4, 2 sine pi 3/8. You see we increase by pi over 8 or 1/8 pi each time until we end up with sine of pi over here. Now I cross out the sine of 0 because it's 0, and the sine of pi because that's 0, and then you just hit pi over 16 times parenthesis, all that garbage, close parenthesis, and you get 1.97. Okay? That is the trapezoidal rule. So, your homework are 5 problems. It is 5 problems, your practice problems. 2 through 10 even. Now it says the instructions use both the trapezoidal rule and Simpson's rule. We haven't done Simpson's rule yet, so just use the trapezoidal rule for that. Have fun.